Hi there, STEM students. For this week, we're going to learn about vectors. We'll start the lesson with physical quantities. Experiments require measurements, and we generally use numbers to describe the results of measurements. Any number that is used to describe a physical phenomenon quantitatively is called a physical quantity. In physics, the physical quantity is expressed in terms of units of measurement. For example, two physical quantities that describe a person are his or her weight and height. To recall, there are 7 fundamental or base physical quantities, namely electric current, amount of substance, length, temperature, luminous intensity, mass, and time. In other cases, we define a physical quantity by describing how to calculate it from other quantities that we can measure. Such a definition is called an operational definition. Thus, we might define the average speed of a moving object as the distance traveled divided by the time of travel. This particular quantity is known as a derived quantity. Derived quantities for other physical quantities are products or quotients of the base units. To make accurate, reliable measurements, we need units of measurement that do not change and that can be duplicated by observers in various locations. Measurement is defined as association of numbers with physical quantities and neutral phenomena by comparing an unknown quantity with a known quantity of the same kind. It is also a size of something measured. The system of units used by scientists and engineers around the world is commonly called the metric system, but since 1960 it has been known officially as the International System, or SI. The table shows the SI units of the fundamental quantities. Prefixes are used to change SI units by powers of 10. To use SI units effectively, you should know the meaning of the prefixes. As shown in the table, the second and third columns list the standard SI prefixes with their meanings and abbreviations, while column 4 gives some examples of the use of multiples of 10 and their prefixes with the units of length, mass, and time. And column 1 shows how these prefixes are used to describe both large and small values through multiples of 10 or 1/10 in exponential notation. For instance, 1 gigameter, where giga is the SI prefix attached to a fundamental unit meter, is equal to 1 billion with factor of 10 to the 9th power, which means 10 is multiplied 9 times. The British system of units are used only in the United States and a few other countries. Here in the Philippines, the SI system of units are utilized. In physics, British units are used only in mechanics and thermodynamics. There is no British system of electrical units. The British unit of time is the second, defined the same way as in SI. The table shows some of the conversion of the British units to SI units. For the quantity length, 1 inch is equal to 2.54 centimeters. For force, 1 pound is equal to 4.448 newtons. For distance, 1 mile equals 1.609 kilometers. For volume, 1 gallon equals 3.79 liters. For mass, 1 slug equals 14.6 kilograms. Some physical quantities such as time, temperature, mass, and density can be described completely by a single number with a unit. When a physical quantity is described by a single number, we call it a scalar quantity. A scalar quantity is a quantity that has magnitude only and has no direction. Scalar quantities are fully described by magnitude alone. It's printed in italic type. Magnitude is always positive. Magnitude is actually a number and a unit, or a size and a scale. Some examples of scalar quantities are mass, volume, density, frequency, temperature, and time. Calculations with scalar quantities use the operations of ordinary arithmetic. For example, 6 kilograms plus 3 kilograms equals 9 kilograms, or 4 seconds times 2 seconds equals 8 seconds. Another type of quantity is called a vector quantity. A vector quantity is a quantity that has both magnitude and a direction in space. We usually represent a vector quantity by a single letter. Also, vector symbols are printed in boldface italic type with an arrow above them, or simply boldface type. Now, when you handwrite a symbol for a vector, always write it with an arrow on top. The arrow is a reminder that vectors have direction. Some examples of vector quantities are displacement, force, acceleration, momentum, and velocity. Vector addition can be done through graphical and analytical methods. Graphical method is used to determine the magnitude and direction of the resultant of two or more vectors of the same kind with the use of a ruler and a protractor. For graphical methods, there are parallelogram for adding two vectors and polygon method for adding two or more vectors, while analytical methods of vector addition and subtraction employ geometry, Pythagorean theorem, simple trigonometry, and component method. These methods are more concise, accurate, and precise than graphical methods. That's it for now. Next time we're going to discuss, or we're going to learn about vector addition. Thank you for listening and good day. Hi there, STEM students. Previously, we learned that scalar quantities can be added through ordinary arithmetic. On the other hand, vector quantities can be added using graphical and analytical methods. So today, we will learn more about these methods. Let's start with parallelogram method. The parallelogram method can be used to add two vectors by placing both of their tails together as shown in step 2, and sketching the two remaining sides that would create a parallelogram in step 3. The diagonal with a common tail represents the resultant vector whose direction is away from the initial vector's origin as shown in step 4. For example, two forces are acting on a particle. Force A is 3 newtons directed north, and the other force B is 4 newtons 30 degrees northeast. Find the resultant force using the parallelogram method. Using a suitable scale of 1 centimeter to 1 newton, draw the arrows representing the vectors from a common point. Then, construct a parallelogram using the two vectors as sides, as shown in the figure, the broken vectors of A and B. Next, draw a diagonal of the parallelogram from the common point which is the resultant, R. Next, measure the length of the arrow representing the resultant and determine its magnitude. Finally, determine the direction of the resultant using a protractor. Thus, the magnitude and direction of the resultant is equal to 6 newtons, 55 degrees northeast. Next type of a graphical method is the polygon method. So first, represent each vector quantity by an arrow drawn to scale. Then, draw the first arrow observing properly its direction as shown in the figure from the left. Afterwards, connect the tail of the second vector to the head of the first vector as shown at the middle. The resultant is the vector that will make a polygon drawn from the tail of the first vector to the arrowhead of the second vector. This is also known as the head-to-tail method, as illustrated in the figure at the right. Next, measure the length or magnitude of the resultant using a ruler, and finally, use a protractor to determine the direction of R. On the first bullet, draw vectors 1 and 2 in succession using a ruler with the tail of each at the head of one preceding it. The sum vector extends from the tail of the first vector to the head of the last vector. Thus, the magnitude of the resultant is 9.5 centimeters, while the obtained value of the direction of the resultant using a protractor is 27 degrees northeast. The second bullet has 3 vectors. Again, draw the 3 vectors in succession using a ruler following the head-to-tail approach. Hence, we obtain 4 centimeters, 70 degrees southwest as the measured magnitude and direction of the resultant. This time, we proceed to analytical methods. The first one is the vector addition having the same direction. If 2 vectors have the same direction, they are parallel. In other words, the magnitude of the resultant is equal to the sum of the magnitudes of the vectors. The direction of the resultant is the same as the direction of the vectors. For example, the 2 vectors 6 newtons and 4 newtons are both have the same direction, so we simply get the sum of these vectors to obtain the resultant. So the resultant is 10 newtons to the right, and also 10 meters also to the right. This time we have vectors acting in opposite direction. In here, when 2 vectors have opposite directions, whether their magnitudes are not the same or are the same or not, they are referred to as antiparallel. Therefore, the magnitude of the resultant is the difference between the magnitudes of the vectors. The direction of the resultant is the direction of the larger vector. In the examples given, simply subtract the magnitude of the 2 vectors to get the resultant vector. So, 6 meters per second minus 10 meters per second is 4 meters per second in favor of the direction of 10 meters per second, which is to the left or westward. Again, 2 vectors are given having the same direction, so the resultant therefore is equal to 6 centimeters upward. Next, we have 5 centimeters and 3 centimeters also in the same direction, so the resultant is 8 centimeters to the right. Next bullet, we have 8 centimeters and 3 centimeters. They are opposite in direction, so the resultant therefore is 5 centimeters in favor of the direction of 8 centimeters, which is to the right. This time, there are 4 vectors. So the first thing that you should do is add all the vectors that are in the same have the same direction. So 3 plus 2 plus 5 is equal to 10. and you subtract that to 9 centimeters, so the resultant therefore is equal to -1 centimeter or 1 centimeter downward. This time, we're going to discuss another or learn another analytical method, and that is Pythagorean theorem. The Pythagorean theorem is a useful method for determining the result of adding two vectors that make right angle to each other. The method is not applicable for adding more than two vectors or for adding vectors that are not at 90 degrees to each other. The Pythagorean theorem is a mathematical equation that relates to the length of the sides of a right triangle to the length of the hypotenuse of a right triangle. So the formula are shown and as follows: square of a plus b squared equals c squared. Also, c squared is equal to a squared plus b squared. To get the value of c therefore is equal to the square root of a squared plus b squared. Now, if you want to find the value of a therefore is equal to the square root of c squared minus b squared. Now, if b is unknown, therefore the formula is b equals the square root of c squared minus a squared. Examples. So two vectors are given, two sides of the right triangle, and we are asked to find for the c. So the formula for c is c equals the square root of a squared plus b squared. Substitute the given values from the formula. We'll be able to obtain the value of c, which is equal to 4.47 centimeters. Next, we have 45 centimeters and 30 centimeters, again sides of a right triangle. We are asked to find the hypotenuse of the right triangle. So c is equal to the square root of a squared plus b squared. Substituting the given values from the formula, we have c equals 54.08 centimeters. So that ends our lesson for today. We will continue with our lesson about analytical method. So thank you for listening and good day. Hi there, STEM students. Previously, we learned that when two or more vectors are parallel to one another, we simply use addition to find the magnitude of the resultant. When vectors are antiparallel, we use the operation subtraction to obtain the resultant and the direction in favor of the larger vector. We also learned that Pythagorean theorem is applicable only for two vectors that are at right angle to each other, and used only to find the length of sides of a right triangle. This time, we will learn about using trigonometry to determine a vector's direction and also the component method. Using trigonometry to determine a vector's direction. The direction of a resultant vector can often be determined by the use of trigonometric functions. First, we recall the meaning of the useful SOHCAHTOA in trigonometry. SOHCAHTOA is a mnemonic that helps one remember the meaning of the three common trigonometric functions: sine, cosine, and tangent functions. These three functions relate an acute angle in a right triangle to the ratio of the lengths of two of the sides of the right triangle. The sine function relates the measure of an acute angle to the ratio of the length of the side opposite the angle to the length of the hypotenuse, operationally defined as sine theta equals opposite divided by the hypotenuse. The cosine function relates the measure of an acute angle to the ratio of the length of the side adjacent to the angle to the length of the hypotenuse. In equation form, we have cosine theta equals adjacent side over hypotenuse. The tangent function relates the measure of an angle to the ratio of the length of the side opposite to the angle to the length of the side adjacent to the angle, mathematically expressed as tangent theta equals opposite side over the adjacent side. The 90 degrees can be obtained using two angles, the theta and the phi. In this example, an adjacent and opposite sides are given, and we need to find the angle theta. So the trigonometric function tangent will be used. So tangent theta is equal to opposite side over the adjacent side. So tangent theta is equal to 4 centimeters divided by 5 centimeters. So tangent theta therefore is equal to 0.8, which is equal, so theta therefore is equal to the inverse tangent of the absolute value of 0.8. Hence, we obtain theta equal to 38.66 degrees. In this next example, in a triangle C, which is equal to 80 centimeters and theta equals 30 degrees, find the values of A, B, and phi. So notice there that A is at the opposite side of the angle while B is the adjacent side of the angle. So A therefore, from here, we'll be able to know what trigonometric function is used in solving for A. So here, we will use the sine. Sine theta equals opposite side over the hypotenuse. So sine 30 degrees equals opposite or the A divided by the hypotenuse. So therefore, A therefore is equal to 40 centimeters. Now to find for the side B, we use the trigonometric function cosine. So cosine theta is equal to adjacent divided by hypotenuse. Why? Again, B is the adjacent side of the angle. That's why we use cosine theta. So cosine 30 degrees is equal to B over hypotenuse. B therefore is equal to 69.28 centimeters. Now to find the value of phi, we simply subtract 90 degrees to the angle theta, which is equal to 30 degrees. So 90 degrees minus 30 degrees, phi therefore is equal to 60 degrees. Okay, the last component, or the last method rather, under analytical method is what we call the component method. So component method is a method employed to transform the vector into two parts, with each part being directed along the coordinate axis. There are several steps to be followed in this method. First, find the x and y components of each individual vector. If a vector is described by a magnitude A and an angle theta measured from the x-axis toward the y-axis, then its components are given by a sub x equals a cosine theta, and a sub y is a sine theta. Some components may be positive and some may be negative, depending on how the vector is oriented. That is, what quadrant theta lies in. You apply the signs of x and y axis in the coordinate system, as shown below. So notice there the four quadrants in the Cartesian coordinate system, wherein x and y have their specific signs. Okay, for step 2, add the individual x components algebraically, including the signs to find r sub x, the x component of the vector sum. Do the same for the y components to find r sub y. So we just simply add all the vectors given along x components. So we can do that by using this formula. R sub x is equal to a sub 1x plus a sub 2x, and so on and so forth, depending on the number of vectors given. Same through with R sub y. We find the resultant in the y component by simply adding all the vectors along y. So a sub 1y plus a sub 2y, and so on and so forth. Next step, we calculate the magnitude of the resultant and the direction of the vector sum using the Pythagorean theorem and the inverse trigonometric function tangent. So in here, to find the magnitude of the resultant, we use the Pythagorean theorem, wherein the formula is r equals the square root of r sub x quantity squared plus r sub y quantity squared. Now for the direction, we use the trigonometric function tangent. So to find the angle, theta is equal to the inverse tangent of x, or the absolute value of r sub y divided by r sub x. Okay, for example, a man in the figure exerts a force of 100 newtons on the wagon at an angle of 30 degrees above the horizontal. Find the horizontal and vertical components of this force. So, the red arrow there is actually the value of the force, which is 100 newtons. And the vertical component here is actually the f sub y. Vertical means upward and horizontal means horizontal. It's the f sub x. Okay, to find the value of f sub x, we will use the trigonometric functions sine and cosine. For f sub x, we will use cosine because f sub x is the adjacent side of the angle. The adjacent side of the angle here. Okay, so substitute the given f sub x is equal to 100 newtons times cosine 30 degrees. Therefore, f sub x is equal to 86.60 newtons. Now, f sub y, let's go back here. F sub y is the opposite side of the angle here. The angle is right here, which is 30 degrees. So that's the opposite side of the angle. That's why the trigonometric function to be used is sine. So f sub y is equal to f sine theta. F sub y therefore is equal to 100 newtons times sine 30 degrees. Therefore, the obtained value of f sub y is equal to 50 newtons. Next example, an airplane flies 400 kilometers west from city A to city B, then 300 kilometers northwest to city C, and finally 100 kilometers north to city D. How far it is from city A to city D? In what direction must the airplane head to return directly to city A from city D? So here's the solution. On the right side, we have here the head-to-tail method, the polygon method of this one. Only the vectors are being plotted. So we have here the distance from city A to city B, which is equal to 400 kilometers. Now, the distance from city B to city C is equal to 300 kilometers. The distance 300 kilometers, 45 degrees northwest. Now, the distance from city C to city D is 100 kilometers northward. So, we are asked to find the magnitude of the resultant, which is the r here, and of course its direction. So the first thing that we should do is we solve the initial vectors into components of x and y direction. Add the components in the x direction to give the r sub x, and add the components in the y direction to give r sub y. So this is what it looks like. So your d sub 1 for the x component is negative 400 kilometers. Why is it 400? Because the arrow is going toward the west. And in this case, this is at quadrant 2, wherein x is negative. That's why 400 here is negative. Now, the y component of d sub 1 is 0 because there's the vector is directed at the x direction only. While d sub 2 is in between the x and y plane. So it is at 45 degrees northwest. So we will use the trigonometric functions cosine and sine for this. For x component, we will use the cosine theta. So d sub 2 cosine theta. Again, we will use the sign of the vector. The vector is again at the second quadrant. So the x here is negative. That's why it's negative 300 kilometers times cosine 45 degrees. The result is negative 212.13 kilometers. While d sub 2 along the x-axis or the y component is sine because it's the opposite side here. So the 300 here is positive because the direction is upward, it's northward. So therefore, the 300 kilometers here is positive times the sine 45 degrees. The result is positive 212.13 kilometers. And d sub 3 is 100 kilometers. For the x component of d sub 3 is equal to 0. Why? Because the vector is at the y axis. Okay, y-axis only. So the y component is positive 100 because the arrow is pointing upward, so it's northward. So therefore, the y here is positive. So we will find the r's of x by adding all the vectors, the three vectors along x component. So negative 400 kilometers plus negative 212.13 kilometers plus 0 is equal to negative 612.13 kilometers. Now for the r's of y along the y component or the y-axis, you have 0 plus 212.13 kilometers plus 100 kilometers. The r's of y is 312.13 kilometers. So next step would be we will find the magnitude of the resultant using the Pythagorean theorem. So the formula is r equals the square root of r's of x quantity squared plus r's of y quantity squared. So substitute the given or the obtained values. We have the square root of 612.13 kilometers quantity squared plus 312.13 kilometers quantity squared. Get the square root of the sum of those two squared. The resultant therefore is equal to 687.12 kilometers. Now to find for the direction of the resultant, we use the trigonometric function tangent. So theta is equal to the inverse tangent of the absolute value of r's of x divided by r's of y. So inverse tangent of this is equal to 63 degrees east of south. So